Find a function of the form y equals a sine kx plus c or y equal a cosine kx plus c whose graph matches the function below. So we can see there's not going to be a phase shift, and where we usually see the omega, they've used a k, but we know that that would be the thing that affects the period. So let's go ahead and look at the graph, and the first thing we want to do is we want to figure out where that baseline is. So we want to make a line that's right through the middle of the function, that the function oscillates about this line. And so we can see that it would be right there, and so that's going to be at y equal 2. So this has a vertical shift up 2, and as we look at the amplitude from that baseline, 1, 2, 3 up, 1, 2, 3 down, they're always going to be the same. So the amplitude is going to be 3. And then we just need to determine the period, and we're ready to build the function because we know there's no phase shift, but we need to decide which function we're going to use. And since we're not going to have a phase shift, we want to see where this function is at 0, and we see this function is at its maximum at 0. So we know this is the equation that we want to use. And we already know C, it's 2 because we're moved up 2, and we already know A, it's 3. That's the amplitude. So now we need to find the k, and we're ready to write that. So let's go ahead and we'll do from a max to a max, and we'll figure out the period. 1, 2, 3, 4, 5, 6. So the period is 6. And so we're going to figure out what our k needs to be so that we have 2 pi over k would need to equal 6. So we know that we'd need a pi so that the pi's would cancel, and then we're going to have over 3. So when we flip it over, it'll multiply to that 2 and give us 6. Again, if you solved that, you could multiply the k over here and divide the 6 over there and see that k needs to be pi thirds. So let's go ahead and write our function. It's going to be y equal 3 cosine of pi thirds x plus 2.